Alright, hello everyone. Welcome to the second part of the POPX Introduction tutorials. If you haven't watched the first part of the tutorials, I highly recommend you to watch it before you continue with this video. So where we left out from the previous tutorial, we were talking about the POPX geometry and how to generate one. And we've built this nice system where we generate some instances and apply some falloffs and transform them at the end to create this nice wavy springy effect. Now, before we continue to explore more of the operators, I want to say something about the system and how to improve this. So each POPX that is connected to another POPX is going to transfer the data of the instances, so the actual geometry. Now, at the end of your network, you will probably want to render this with a rendered setup. And to make it more efficient, each of the POPX on its common tab has a render primitive toggle. And to make the system more fast and lower the memory on the GPU and CPU, you will typically want to toggle off all of the render primitives on each of the POPX operators. And at the end, you will have a geo to basically uh, have it render the final result. So to do it, you can select all and just go to the comment tab of one of them and toggle off the render. And what you can see now is that they're no longer rendering the instances, and only the geo is rendering, because in its comment tab the render primitives it's on, so we can display the geo over here. You can also do it by pressing Control Shift R. So if you select a POPX and toggle the and press the Control Shift R, it's going to um, do it for you. It's a keyboard shortcut for this. And you can select them all also and press the Control Shift R to do this as well. All right, so the geo also, you can apply some materials for each instance. So if you go to the instances page, you can see that I have two materials, and this is because I have two types of geometry that is being instanced. We have the sphere and we have the box. So I can apply basically a material for each of one of them. So for example, I have a PBR, I can reference it in the first one, and now my boxes will have like a PBR material. And I can also create another PBR material and apply it to the sphere, for example. Now I'm going to actually select all of the operators and press Control Shift F, and this is going to basically um, toggle off any preview falloff that the operators have, because I want them to not have the color of the falloff, and I want the color to come from the material. So for example, for these boxes, I can have like bluish color, and for the spheres, let's have like a red color. So this is a nice way to basically apply a material for each one of the instances. And obviously, if you add more instances, So if you press the plus over here, you can insert, for example, a torus, and you will see that automatically you'll have another material parameter here, and you can apply also the material for the torus. Maybe have it a green color. All right, so let's delete this system and build and explore more systems with other operators. So I'm going to delete it. So let's explore more of the modifiers. Let's start with the aim. So the aim modifier basically changes the orientation of the instances based on uh, a aim vector or and the up vector. So the aim vector is basically the forward direction of the instance, and you can choose whether you want to aim at a object or a vector or at points. So let's see it in action. Actually, I'm going to instance boxes, and let's make it a grid distribution, but actually let's make it like a 3D grid. And I'm going to scale them down a bit more, something like that. And now if I connect it to the aim, and I'm going to display the aim, you can see that I have like the aim guide, which is the bluish circle, and I can change its position, and you will see that my instances are basically uh, facing the position of the sphere. Now to see it better, we can visualize the frame. Let's scale it down a bit. Actually, I'm going to display both so I could see the aim guide. And to where I move this the guide, the object, my instances are going to face it. And also you can choose the up vector. Currently it's set to a vector which is this one, and you can also change it, and it will change basically the green axis, which is the up vector. Let's reset this. You can choose the in the orientation tab whether the aim is actually the z-axis or the y-axis or any other. So also the up axis. Let's keep it by default, and you can invert the aim or invert the up vector or constrain around the up vector. This will change the orientation. And you can also do a fall off for this. So, for example, if I create, for example, let's do like a noise fall off, okay? And let's connect it like this. And let's visualize the fall off. And let's change a bit um, the harmonics and frequency. So you can see that um, maybe let's change the exponent to like very low. So you can see that we created like regions that the falloff is 100%, like one, and regions that, or another region that it's zero, and only the parts that are one are aiming towards our object. Let's actually bypass this falloff, or we can also just um, not do the falloff. But let's actually bypass it. And to bypass any POPX operator, you can also press Ctrl Shift B, and this will bypass your selected operator. Now, another option, you can choose between the aim vector or aim object that we're currently using, or aim at points. Now, this you'll get an error because we don't have anything connected to the aim target. So what we need to do is basically insert some geometry. For example, um, let's do a torus and insert this, and let's display. Actually, we don't need to display the torus. The torus is going to be displayed over here, but we're going to change maybe the radius over here like this. So what will happen is the instances are going to uh, be aimed at the closest point on the torus that they had. So if I make it like this, you can see that they are going to be aimed at the torus at the closest point on the torus related to them. And you can basically do the same for the up vector. So I can insert, for example, a sphere, and in the up vector choose points. And let's scale the sphere down. And you can see that the um, up vector is pointing towards the sphere. And you can obviously animate those geometries and create a nice variation of like rotation and or orientation of your instances. All right, so let's delete this and move on to another nice modifier. Let's start with the move along mesh. So the move along mesh will basically take your instances and kind of like move them along the surface of the input mesh. So I'm going to start with the simple sphere as the mesh, and I'm going to insert my grid of boxes into the move along mesh. Let's display it. And yeah, something weird is happening because we don't have any mesh in the input. So I'm going to insert the sphere, and I will add a keyboard in to reset the move along mesh, which is basically a small solver, and reset. And now you can see that our um, boxes are being moving basically along the surface of the sphere. And you can also play around with the animate tab. So I'm going to enable the lifetime and maybe scale them also by the age. So it will be much more smoother, because without it, you can see that it's flickering a bit. And now if I scale by their age, they're starting to grow smoothly. And you can play around with the ramp that defines the scaling. Now let's visualize the local orientation also with the visualize frame. I'm going to connect it, and you can see better the effect that our instances are basically moving along the y-axis, so the up vector of the mesh, and their forward direction is pointing outwards, like the normals of the sphere. Now, to make it more interesting, I can define different orientation for the sphere. And to do that, I'm going to use the Orient Mesh. So the Orient Mesh will take any mesh and compute an orientation field basically on each point of the mesh. And you can visualize let's actually turn this off. And you can visualize um, the orientation, visualize the up vector. And you can choose different compute methods to generate different kind of um, orientation. You can see like from polygons uh, creates, I would say, more kind of like a curly effect. And I can increase maybe the frequency to maybe show it better. And you can also change and invert the up vector or the normal, or make a cross between them and output the tangent. Now, a nice thing you also can do is to enable a curl noise. And this will apply a curl noise on the orientation. And you can blend between the original and the noise. Let's keep it at 0.5. And you can also animate this noise. So I'm going to type uptime.seconds and multiply by 0.1. So basically I have an animated orientation frame. Also, you can enable blur to blur out a bit um, this field of orientation. And now I will connect the Orient Mesh onto the Move Along Mesh, and the Move Along Mesh will use this new orientation. So let's display this. I can also increase maybe the number of instances. The Move Along Mesh also have an attach page. Currently, I'm using the attach mode nearest point, but I can just randomly scatter the points onto the sphere mesh. Let's scale them down a bit in the global transformation. And maybe to see the effect better, I'm going to scale them on their y-axis. So the y-axis is facing towards the movement. Another thing is nice to do is to enable the point relax. This will separate those instances so they won't overlap. You can increase the relaxed iterations, but this will be probably heavier. So I think a relaxed iteration of 1 is good enough, maybe 2. And we can maybe reduce the max neighbors with this example. Now, a cool thing we can also add is using the trail pop to add a trail based on the path that these instances are taking along the surface. So for doing that, first I'm going to output the life attribute, and this is going to basically, if I create a null, this is going to output the age and the lifetime of my instances. So I'm going to connect them to a trail, and if I display the trail, I can see there is a bit of like flickering and stuff that we don't want. Let me also reference the keyboard in to reset the trail when I'm resetting the simulation. Now to um, basically get rid of these, what I need to do is to delete uh, points that are just got born, basically, that based on their age. So I'm going to delete, but I'm doing uh, split line strip in the line strip behavior, and I'm going to choose the age attribute that was output from the move along curve, and I'm going to maybe increase a bit the value over here, and let's display the delete. And now I have the trails much more nicer. Let's look at them from here. We can see them better. Another nice thing we can do is to apply some um, maybe coloring based on the age. So I'm going to first convert those trails into a regular pops with the POPX 2. And this is going to basically just uh, convert them into a regular pop, and the data from the other POPX won't get interfere with the rest of the system. And I'm going to apply a color modifier to the trails. Now, as you can see, um, it's something that it's really important to say that all the POPX operators can also work with just regular pops. So here, for example, we're using just trails that were generated by the trail pop, but we can still apply and modify them with the modifiers. So I'm going to, instead of the POPX Falloff, to choose the age attribute that we created. And now you can see that the color of the trails are based on the age. And you can obviously play around with the color ramp. And we can also toggle on the instances, or maybe a better way is to create a geo and connect the move along mesh, and I'm going to toggle off the render primitive on this and display the geo. Maybe let's decrease the size a bit more and reset the simulation. And now we can see the path that each instance is making along the surface of the mesh more clear. All right, so this was the move along mesh. Next, what I want to show you is the move along curve. So I'm going to delete this system over here, and I'm going to keep the instance here. for now, but I'm going to make it equally scaled. Now the move along curve um, operates very similar to the move along mesh, but it's actually moving the instances along a curve that we connected to it. So I'm going to drop it and connect my instancer to the curve, to the move along curve, and I need to define a curve. So I'm going to use a simple pattern pop, connect a null to it maybe, and connect it into the move along curve. Okay, so now to start moving it along the curve, we need to uh, press the start. And you can see that immediately they're snapped into the curve. Currently, we're using the simple mode, which is not a solver. Um, so we can manually basically move them along the curve by going to the animate and increase the glow. And also wrap is also toggle on here, so they're going to wrap. Um, but for this example, let's use the solver mode, which will just make it automatically. And I can insert another, again, a keyboard in to reset my solver. Now, if I want to attach the instances in a different way, I can choose to do it with the attach mode to distribute them across the curve, and now they're distributed across the curve, and I can reduce maybe the amount of instances to see it better. All right, so before we're choosing the nearest point on the curve, so multiple instances can be attached to the same point on the curve, and to better see the effect, you can just distribute them. Here in the curve select mode, you can also choose between a primitive index. So currently we have only one primitive, so we can choose the primitive index 0, and if we change it, there will be no effect, but I can maybe copy the pattern over here, and let's maybe transform it a bit to not be in the same position of the other pattern, and merge them two together. Now you can see that if I reset my simulation, the other um, curve doesn't get any instances because we're choosing to um, uh, only instance on the primitive index 0, but I can choose to do it with the primitive index 1, and they will be in the other one, or use the nearest point on any curve. So apparently now they're all closer to the this one, but I can also use distribute, and this will distribute them evenly in on the all the cores that we input. Now there are many options here on the attach curve. For basically you can maintain the offset from the curve. So originally the offset is basically um, the distance between the original position and the curved position. We will look at another example of this in a minute. You can also maintain the orient offset, so automatically the instances will be orient by the orientation of the curve, but I can change it so that they won't be oriented anymore by the curve by increasing the maintain orient offset. And each of these parameters has a ramp, so you can basically to change it across the curve. Now, to basically make all of this happen, the the main problem here is to get the correct orientation of the curve. And to do that, we are enabling the reorient input curve. So for a more complex curve, if you toggle this off, um, there will be um, some problems on the orientation. You can see they are not longer orient correctly. But if I reorient the input curve, you can see that they are much more correct in the orientation. So internally, what it's doing, it's using the where is it? The Orient Curve tool that takes an curve as an input, and basically using a parallel transport, it's going to reorient the curve to the correct way. Maybe to visualize it better, let's input the um, one of the curves over here into the orient curve, and with the visualize frame, which I deleted, so I'm going to put it again, we can see the effect. So you can see now that the orientation axes are correctly representing the orientation of the curve. But if I bypass the orient curve, so I'm getting an incorrect orientation. And this is more notable if I, for example, use a noise on the curve itself. So I won't get any clean orientation. And if I unbypass this, so you can see that the orientation is correct. So without this, the move along curve won't work um, correctly. And you can also um, apply some twisting. So for example, if I increase the twist curve amount, maybe if I increase my instances, you will see this better. And actually, let's create just one. And maybe let's also animate it less fast. So by decreasing the speed over here, and the twisting is basically twisting along the curve. And you could play with the twisting ramp also to have it affect on different regions of the curve. Maybe let's increase it more like this to see the effect of the twisting. And maybe let's play around with the curve a bit, scale it down like this. In the animate tab, I can also scale the um, instances by the goal. So the goal is basically it's their position along the curve. So this makes it much more nicer. And you can also twist it again here in the Animate tab to further twist it. Let's not do adapted to ohm, so I can, yeah. You can also toggle off the align to curve, reverse the um, the operation, and you can also choose between arc length or go. This will operate a bit differently, and you can randomize the speed maybe to make more variation. Now, a nice thing you can also do is to output the go attributes by toggling on the output goal attribute, and this will output two attributes, which is the curve index that the instance is being attached to, and the goal u, which is its current u position on the curve. So then you can basically uh, visualize it. For example, with a color, I can choose the color modifier, and if I change it to goal u, you can see uh, that the color changes according to the goal u. In the animate tab, you can also affect the speed and the rotation based on a falloff. So if you create any falloff before the move along curve, you can choose it over here. Now let's see how we can make it much more cool. For example, I can change the distribution of my instances to be instance on the curve itself. So for that, I'm going to change it here to be curve, and I'm going to reference my curve in the template object. And as you can see, we have our instancer in our curve distribution. Now, if I'm going to choose, for example, the nearest point, and I'm going to increase the maintain offset. Well, something is wrong here. Hmm. Let me just. I'm not sure why it's not working right now. Oh, of course, because we're trying to maintain an offset, but we don't have an offset because we're initially distributed inside on exactly on the curve. So what I was meant to do is to create maybe a randomize and randomize the positions before we are connected into the move along curve. So I'm going to randomize the position a bit and maybe do it much less. And then I can maintain my offset and the attach mode maybe to be nearest point. And maybe I can increase the randomize a bit. So now we have we are maintaining the offset from the curve, and we can have this look, which is they're still kind of like moving along the curve, but they have like a nice offset from the curve. And you can also visualize the offset. So if I go to here, like this, you can see that there is like yellow lines that are visualizing the offset. And you can play with the offset ramp. So currently it's white completely. But if I, for example, want for the beginning to not have an offset and only in the middle maybe have the offset applied, and maybe let's make them a bit smaller, and maybe increase the randomize. And this is a very nice visualization of what's happening. If you want to get those lines, actually, you can press the fetch offset lines, and this is going to create an offset line select up with those lines. So you can render them and play around with them. Right. So um, I hope this was useful for you. And this is where I finished this part of the tutorial. And in the next tutorial, we're going to look deeper and explore more modifiers, more falloffs, and tools. So hope to see you in the next tutorial. And yeah, I'm excited to show you what the POPX system can create for you. Bye bye.